Okay, so now we are at 8.3. That is the observed significance of a test. So the observed significance of a test, we call it the p-value. So this is the p-value approach. The first that we did for the 8.2, we used that of the critical value approach. But all of these, we are using what? The last sample in testing the population what parameter mu. Okay, so in case you don't want to use the critical value approach in making a decision, you can use the p-value approach. So the steps actually hold, but for now, you wouldn't determine the z alpha or z alpha over 2. All you need is to determine what? The p-value. So for the z alpha or z alpha over 2, first of all, what we needed was the direction under HA or H1. And we needed our alpha, okay, to find our z alpha or z alpha over 2. But in the p-value, what we need is the direction under H0 and under HA and the z value. Okay, so these are the two things that we need in order to find our p-value, and we can make decisions. So that is the summary. So this is how the rejection region is. So if you're using the p-value to make your decision, one, so if your p-value is less or equal to your alpha, then reject H0. And if your p-value is greater than alpha, then fail to reject H0. That's all. So all you need is to find your p-value and you can make conclusion. So it's just the direction, your z value, or the statistic value to make. So without much that we do, let's go through some of the examples. So first of all, we needed a direction. So from this example, under the HA, we are going to the left, and the z value or the test statistics value that we have been given is minus 1.72. So the p-value is written as this based on the direction. So you write probability. So with respect to A, you write probability of z less than based on the direction, then you bring your value minus 1.772. Okay, so you write this. So this is the p-value. How do we do this? Remember, in previous chapters, you've been able to find the probability of our z. So what you do is that you use your normal CDF. So your normal, so we pick from minus 1.72 to what? Negative what? Infinity. So minus 72 will be your upper value, and any value that you choose will be what? Your lower value. So you use your calculator, and so you hit the second, and you choose VAS, then you go to the normal CGF, that is 2. Okay, so you choose your lower. So your lower will be any value. So minus maybe 100. Then your upper value is minus 1.72. Okay, then you hit enter, then you're good. That will be your p-value. So this is the p-value. That is how we calculate it. That's all. So if you get this p-value, you compare it with your alpha in case you want to make decision. So now the alpha is same as level of significance or significance level is different, and the p-value is observed significance. So note their difference. So now we want to make our decision. So what we had from this p-value, what we had for this p-value is that we had 0.042. Okay, so that is the answer here. As you see, that's 0.0427. All right, so that's the p-value. We compare it with our alpha. So based on comparison, what do we do? We're seeing that if our p-value is less than or equal to alpha, then we reject H0. If it is greater than, then you fail to reject. So if you compare it with alpha of 0.05, we realize that it is less than it, then we reject H0. So that is the decision that we make. But if you choose an alpha, which is 0.01, then our p-value is greater than it. So we fail to reject H0. That is all. You're good. So you do same. So now, but here, we are using not equal to, so it's two-sided. So what you do is that since two-sided, it could be less or it could be greater. So when it comes to two-sided, we could have the direction to this side or to that side. Okay, this implies that if we do for this side, okay, the answer that we get will be the same for what? That side. So your p-value, you have to multiply it by 2 before you compare it with what? Alpha. So always, if you have two-sided under the HA, the p-value that you get, please multiply it by what? 2, or add it twice to get your actual p-value. So we can do for one of the directions. Okay, so with respect to this, I'm doing this now. So if we have probability of z, maybe I'm going the left direction. Okay, so it's less than minus 2.07. Okay, then I do the normal CDF just as I did. So you hit the second, you choose the verse, then you choose the 2. So you hit it again. So we are picking it from what? Minus 2.07 to negative infinity. So 2.07. I'm done. So I paste it, but this is not my actual value. So I have to multiply this what? By 2. This is just one side, but it's two-sided. So add this twice, or you have to multiply your answer by 2. So times what? 2. So this would be your actual what? P-value. Then you compare 0.038 to your alpha, all right? Then you are good to go. So that is what we did. So if you compare with alpha of 5%, what you get is that we are less than it, so we reject it. If you compare it with alpha of 0.01, then we fail to reject it based on the criteria given. So we do same for all the directions. So always, if you have two-sided, you multiply your p-value by 2. But if it is one-sided, please just use it like that. Okay, so now we have a full question for which we have to apply our p-value to it, or we have to use. So now you have to make your decision whether you have to use the critical value approach or the p-value approach. All of them will give you the same conclusion. So in this scenario, we are using that of the p-value approach. So we figure out the things that we need. So first of all, you have to write your hypothesis based on the question. So the hypothesis, the mu is, so we have the direction going to the left based on the question. We have less than. So less than 202.5 means that we are going in this direction. This is where our claim is. Okay. So since we are going this day, we calculate our z value. Note that for previous examples, we've already been given what? The z value, but now we have to calculate the z value before we can use the p value approach. So p value approach, you need your z value and the direction. You need this direction and you need the figure here. Then based on the direction, then we can write probability that our z is less than a certain value that the z picks. So we don't know, so let's write it like k. Okay, so based on this direction, we can get it from our calculator using the normal CDF. If you get that, then since we are at one direction, we compare it with our alpha, make a conclusion. That is what we did. Okay, but there's something also interesting when it comes to the p-value. In case you have a question like this and you want to calculate using your calculator, then the calculator will already give you your p-value. Okay, in case you draw it or use the calculate. So based on the details that we input, if you want to get your z-test, then you are saying that go to the stats and go to tests. Choose the first one, the z-test, and you're good to go. Input the mu naught. So the mu naught is 202.5. That is 202.5. And your sigma is 19.63. 19.63 based on the question. And your S bar is 199.2. 199.2. And the sample size is 85. And which direction are we going? We are going to the left direction, so you choose this one, then we hit enter first so that it keeps on blinking. So now if you hit calculate, you're going to get your p-value. So under z, you get your z-value, you get your what? Your p-value as well. So the p equals what? The p-value. This is just one direction. But if I'm to change the direction to two direction, you realize that my p-value doubles. So now it's 0.0605. If I change it to two directions, so if I hit enter, go to and choose what? 1. For now, I'm going two directions. So that is this. This is the two direction. Realize that it multiplies by what? 2. So now my p-value is 1.12.1211. Okay. So the calculator do everything for you based on the side that you are going. So now you can compare the p-value to your alpha based on the direction that you are going. Okay. So we do that. So the alpha given was what? 0.05. Since we are doing one direction, this is greater than it. If it is greater than it, what do? We say we fail to reject it or don't reject what? H0. That's the decision that we make. All right. So we do same for all these questions and you're good to go using your calculator. Okay. So in case you have problem using the calculator, please do well to email me and I'll be glad to take you through. So all of these, we are using what? The calculator and how to get a p-value. Okay, there's an example that is very interesting here. So out of the question, we want to know our point estimate for. The point estimate is your S bar. So from this question, out of the sample, we have sample average is 8.7. So that is your S bar. And find the 95 confidence interval for the mean of the college. So we've gotten to know how to find the confidence interval. So you go to your calculator and you go to what? Stats. Test and you go to z interval. Okay, if the sample is large, then you input the necessary details there. So your sigma, you enter your sigma. So the sigma in the question, the standard deviation, that is 1.1. And the S bar is 8.7. The sample size in the question is 45. And the confidence level is 95, so 0.95. So now you calculate. So this gives me what? My 95 confidence what interval using the calculator. We have a way of also doing it. I think we've done that before. Okay. So now by the C, we are saying that suppose that the US national average for movie visit in there. Okay. So we have our mu now to be what? Our mu now to be 9. Okay. Can you reject the null hypothesis that the population mean for the college students is the same as the mean for the general? So now can we reject our null hypothesis? Our null hypothesis that the average for movie visits in a year is 9. That is mu equal to 9. This implies that the alternative will be mu is not equal to what? It's not equal to 9. Okay, so this is our hypothesis. But without testing, what we do is that if we find your mu within the confidence interval that you've created, then do not reject the null hypothesis. If you find your mu within the confidence interval, so this is a way of also what? Making a decision. You can find a confidence interval based on the information that you have, and you choose which of them. If your the mu value given, if it is within the confidence interval that you've created, this interval, so you realize that 9 is within this interval, so we fail to reject the null hypothesis. But if the interval was like 7 to 8 and mu is given to be 9, the mu is not in the interval, so then we reject the null hypothesis. Are you okay? All right, based on each direction that we go. So this is a way of actually making conclusion, right? Using what? The confidence interval. So if you read this, it will explain everything for you. If you have questions, please do or to email me. Thank you very much.